Welcome back to Database Internals Crashcasts. I'm Sheila, and before we dive into today's topic, I'd like to remind our listeners to rate our podcast on your favorite platform. Your feedback helps us improve and reach more database enthusiasts. Now, let's get started with our exciting topic for today, single-tier architecture. We're currently in Chapter 3 of our Introduction to Databases season, focusing on database architecture. Victor, I've got a quiz question to kick things off. Are you ready?
Absolutely, Sheila. I'm always up for a good database challenge. Let's hear it.
All right. Here's the question for our listeners. In a single-tier architecture, where does the database typically reside? A. On a separate server. B. In the cloud. Or C. On the user's device. Take a moment to think about it, and we'll reveal the answer at the end of the episode. Victor, what are your thoughts on this question?
That's an interesting question, Sheila. It really gets to the heart of what single-tier architecture is all about. Without giving away the answer, I think it's a great way to make our listeners think about the structure and components of this architectural model. It also highlights the unique characteristics that set single-tier apart from other database architectures we'll be discussing in this chapter.
Excellent point, Victor. Before we dive deeper, could you give us a brief definition of single-tier architecture? I want to make sure our listeners have a clear starting point.
Of course, Sheila. Single-tier architecture, also known as monolithic architecture, is a software design pattern where all the components of an application, the user interface, business logic, and data storage, are combined into a single program that runs on a single platform. In the context of databases, this means that the database management system, application logic, and user interface are all tightly integrated and typically run on the same machine.
That's a great explanation, Victor. So, if I understand correctly, it's like having all the ingredients of a meal in one pot, rather than cooking them separately. Is that a fair analogy?
That's an excellent analogy, Sheila. Just like a one-pot meal, single-tier architecture combines all the elements in one place. This approach has its advantages and disadvantages, much like how a one-pot meal might be convenient, but could limit your ability to customize individual components.
Interesting. Can you tell us a bit about the historical context of single-tier architecture? When and why did it first come into use?
Certainly, single-tier architecture dates back to the early days of computing. In the 1960s and 1970s, when mainframe computers were dominant, most applications were built using this model. Back then, computing resources were scarce and expensive, so it made sense to have everything run on one powerful machine. Here's a fun anecdote. The first IBM PC, released in 1981, often ran single-tier database applications. Users would insert a floppy disk containing both the database and the application, and everything would run locally on that one machine. It was a far cry from today's distributed systems, but it was revolutionary at the time.
Wow, that's fascinating. It's amazing how far we've come. Now, I'm curious about the advantages of single-tier architecture. What makes it appealing in certain situations?
Great question, Sheila. Single-tier architecture has several advantages. 1. Simplicity. With everything in one place, it's easier to develop, deploy, and maintain. 2. Performance. Since there's no network communication between components, operations can be very fast. 3. Data security. All data stays on one machine, which can be easier to secure physically. 4. Offline capability. Applications can work without an internet connection. However, it's important to note that these advantages come with trade-offs, which we'll discuss shortly.
I see. So, it seems like single-tier architecture might be well suited for certain types of applications. Can you give us some real-world examples where it's still used today?
Absolutely. Single-tier architecture is still relevant in several scenarios. 1. Desktop applications. Many personal productivity tools like text editors or small databases for personal use. 2. Embedded systems. Think of a point-of-sale system in a small shop or a kiosk application. 3. Mobile apps. Some mobile applications that don't require constant server communication use this model. 4. legacy systems, older systems that haven't been migrated to modern architectures. Remember, though, that as applications grow in complexity and scale, they often need to move beyond the single-tier model.
That makes sense. Now, you mentioned trade-offs earlier. What are some of the limitations or disadvantages of single-tier architecture?
You're right to bring that up, Sheila. Single-tier architecture does have significant limitations. 1. Scalability. It's difficult to handle a growing number of users or increasing data volume. 2. Resource-intensive. It can be demanding on the client machine, especially for complex applications. 3. Update challenges. Distributing updates to all users can be cumbersome. 4. Limited data sharing. It's not ideal for applications that need to share data across multiple users. 5. Security concerns. If the client machine is compromised, both the application and data are at risk. These limitations are why many modern applications, especially those dealing with large amounts of data or multiple users, opt for multi-tier architectures.
I can see why multi-tier architectures have become more popular. It seems like single-tier architecture is quite different from what we typically see in modern database systems. How does it compare to other architectural models we'll be discussing in this chapter?
Excellent question, Sheila. Single-tier architecture is indeed quite different from other models, like 2-tier, 3-tier, or n-tier architectures. The main difference lies in how responsibilities are distributed. 1. In a 2-tier architecture, we separate the database from the application logic and user interface. This allows for better data sharing and centralized data management. 2. 3-tier and n-tier architectures go further, separating the user interface, application logic, and data storage into distinct layers. This separation allows for better scalability, easier maintenance, and more flexibility. 3. Client-server models, which we'll discuss later, distribute responsibilities between client devices and servers, allowing for more efficient resource utilization. Compared to these, single-tier architecture is simpler but less flexible and scalable. It's a bit like the difference between a Swiss Army knife and a full toolkit. The Swiss Army knife, single-tier, is compact and self-contained, but a full toolkit, multi-tier, offers more specialized tools for complex jobs.
That's a great analogy, Victor. It really helps put things into perspective. Now, I'm curious about best practices. For developers working with single-tier architectures, what are some tips or tricks they should keep in mind?
Great point, Sheila. Even though single-tier architecture is simpler, there are still best practices to follow. 1. Modular design. Even within a single tier, strive for modular code to improve maintainability. 2. Local caching. Implement efficient local caching to improve performance. 3. Regular backups. Since all data is in one place, robust backup strategies are crucial. 4. Security measures. Implement strong encryption and access controls to protect the application and data. 5. Update mechanism. Design an efficient way to push updates to users. 6. Resource management. Optimize resource usage to avoid overwhelming the client machine. Remember, while these practices help, they don't overcome the inherent limitations of the single-tier model.
Those are valuable tips, Victor. As we wrap up, could you summarize the key points about single-tier architecture for our listeners?
Certainly, Sheila. Here's a summary of the key points. 1. Single-tier architecture combines user interface, business logic, and data storage in one program on one platform. 2. It originated in the early days of computing and is still used in certain scenarios today. 3. Advantages include simplicity, performance for local operations, and offline capability. 4. Limitations include poor scalability, update difficulties, and security concerns. 5. It's suitable for certain desktop applications, embedded systems, and some mobile apps. 6. Modern complex applications often require multi-tier architectures to overcome these limitations. Remember, single-tier is like a one-man band, impressive for small venues, but not suitable for a symphony orchestra.
That's an excellent summary, Victor. Now, let's reveal the answer to our quiz question. The correct answer is C, on the user's device. In a single-tier architecture, the database typically resides on the same device as the application and user interface. Before we sign off, I'd like to remind our listeners to visit crashcasts.com, join our Discord community, and support us on Patreon if you're enjoying our content. Your support helps us continue creating these educational episodes. Thank you for tuning in to Database Internals Crashcasts, and we'll see you in the next episode where we'll dive into two-tier architecture.